Section 9.1 of your textbook covers a method of solving quadratic equations by using the principle of square roots. The principle of square roots states that if x squared equals some number, then x must be a square root of that number. Or expressed algebraically, it states if x squared equals k, then either x equals the square root of k or x equals the opposite of the square root of k. Note that the notation x equals plus or minus the square root of k is often used as a shorthand notation indicating that x equals the square root of k or x equals the opposite of the square root of k. Let's look at this principle used in solving quadratic equations. Our first example is n squared equals 25. Note that we could solve this equation by subtracting 25 from both sides, then factoring the binomial n squared minus 25 and using the principle of zero products. However, we can use the principle of square roots to state that if n squared equals 25, then either n equals the square root of 25 or n equals the opposite of the square root of 25. Well, since the square root of 25 is just 5, we have two equations, n equals 5 or n equals negative 5, and therefore our solution set contains the numbers positive and negative 5. The real power of the principle of square roots, however, is demonstrated by example number 2, in which we have a binomial negative 3x squared plus 7, which cannot be factored, and therefore we can't use the principle of zero products to solve this quadratic equation. Instead, we'll isolate x squared, first by subtracting 7 on both sides, then by dividing by negative 3 on both sides, to obtain x squared equals 7 over 3. Now using the principle of square roots, we see that x equals plus or minus the square root of 7 over 3. Rationalizing the denominator by multiplying by the square root of 3 in the numerator and the denominator, we obtain x equals plus or minus the square root of 21 over 3. And those two irrational numbers are the solutions of our quadratic equation. Let's look at two more examples. Example number 3, the quantity y plus 2 squared equals 4. Once again, we can use the principle of square roots. So we have two equations, y plus 2 equals the square root of 4, or y plus 2 equals the opposite of the square root of 4. Simplifying the square root of 4, we have y plus 2 equals 2, or y plus 2 equals negative 2. Then solving each of these equations for y by subtracting 2 on both sides, we obtain y equals 0, or y equals negative 4. So the two solutions of our quadratic equation are negative 4 and 0. Finally, example number 4. Notice that the left-hand side of this equation, x squared minus 8x plus 16, is a perfect square trinomial. Therefore, we can factor it as the quantity x minus 4 squared. So the quantity x minus 4 squared equals 90 is our equation. And once again, we use the principle of square roots. And we can write x minus 4 equals plus or minus the square root of 90. Adding 4 to both sides of this equation, we have x equals 4 plus or minus the square root of 90. Since the square root of 90 is not in simplest radical form, we will factor out the square root of 9, which is 3, and write our solutions as 4 plus or minus 3 times the square root of 10. Those two irrational numbers, 4 plus 3 times the square root of 10 and 4 minus 3 times the square root of 10, are the solutions of our quadratic equation.